This is the video for lesson 45. We've learned how to factor terms that are perfect squares tied together by a negative sign. And factoring them renders you with binomials that are conjugates. Remember, we take the square root of both terms, x minus 2, x plus 2 equals 0. And the answers are the same answer, just the opposites. So for x minus 2 to be 0, the answer for x would have to be 2. For x plus 2 to be 0, it would have to be negative 2. So we could say x is plus and minus 2, right? Now, in lesson 45, our variable is going to be a perfect square, but our number is not. But we can use this same procedure and get a correct answer. Remembering I had plus and minus of the same number. So if I have x squared minus 3 equals 0, I can factor it using the same procedure by isolating my squared term. So I'm going to move my 3 to the other side, and I have x squared equals 3. And to eliminate my square, I'm going to take the square root of both sides, and x is going to equal plus and minus the square root of 3. It has to be both plus and minus, okay? One is always positive, one is always negative. All right, just in the same manner that when we had the conjugates with the perfect square terms, you had plus 2 and minus 2, okay? Now, our term doesn't have to be a single variable. We can also have a binomial squared and do the same thing. So if I have x plus 17 squared minus 2 equals 0, I have one term squared, so I can move my 2 to the negative side by adding 2 to both sides, and I end up with x plus 17 squared equals 2. I can eliminate my square by taking the square root of both sides, and I have x plus 17 equals plus and minus the square root of 2. But I'm not done. I must continue to solve for x by moving my 17 to the other side. We do that by subtracting. So my answer is x equals plus or minus the square root of 2 minus 17. And this is my answer. Look at example problem 45-2. In example problem 45-2 on page 201, it asks you to solve x plus 2/5 squared equals 3. I have a perfect square on the left, and I can therefore take the square root on the right. It's isolated. So I take the square root of both sides. Remembering when I take the square root of the term on this side, it's plus and minus, okay? So I have x plus 2/5 equals plus or minus the square root of 3. I move my 2/5 to the other side to solve for x, and I have x equals plus or minus the square root of 3 minus 2/5, okay? All right, you have to remember it's plus or minus, right? Because, let me explain this a little further. If I had the square root of 4, couldn't the square root of 4, to get a positive 4 under the square root, couldn't I multiply positive 2 times positive 2? Yes, that's 4. I could also do negative 2 times negative 2. So that's why your positive and your negative must be on the outside. Okay? And you always must solve for x. So back in 45(2), we had x equals plus minus the square root of 3, right? Square root of 3 minus 2/5. We could actually solve for this, can't we? With your calculator, you could. But this is a sufficient answer, okay? And it doesn't matter, you could write it either way. Plus or minus, you could write negative 2/5 plus or minus the square root of 3, okay?